Well, thank you for welcome, all of you. Thanks for coming. Now that we're all loaded up on massive carbs and we can sit through about 800 slides on securing Hadoop at scale. So hopefully you guys are ready for that. My name is Peter Guerra. This is my colleague Drew Ferris. We're both from Booz Allen Hamilton. We are part of our data science group. We help run very large clusters for a number of clients across both US federal as well as commercial clients. And as part of that, what we thought we would do is share some of our overarching kind of lessons learned that we've observed after working with all these clients, and just tee up some discussion, if you will. And this is, should be interactive. So if there are questions that you have as we're talking, or things that we're saying that you just maybe don't jive with what you know or whatever, then raise your hand and let's talk about it. So I appreciate that. When working with a lot of our clients, we have noticed kind of two different ways that they've approached securing their Hadoop clusters. The one is, basically no security whatsoever. They just deploy the Hadoop cluster, they hope for the best, data gets poured in there, they have really no idea who's accessing it or what. That's just one end of the spectrum. The other end of the spectrum tend to be very locked down, but kind of empty or hollow inside. So meaning you have a single door and you control access by user and so forth. They put it in an enclave with a firewall and they say, okay, we have people authenticating to it and therefore all of our data is safe and we're compliant and all that stuff, which isn't the case. What we really noticed though is, this is a picture of Amsterdam in the 1500s, and Amsterdam at that time put a huge amount of money into building this wall all the way around to withstand like medieval sieges. And as soon as they built the wall, it took them about 20 years and lots of tax dollars. They had taxes back then too. It was obsolete by the time they actually built it. And that's what we're noticing a lot with our clients is this ecosystem is moving so quickly. There's so much consolidation. Even this morning, saw the announcement of Cloudera acquiring Gazang. There's just so much going on in this space that a lot of times when we go with our clients, we build infrastructures, 6 months down the road, ecosystem is completely changed on them. And so how do you address that? How do you deal with that? And what are some of the best practices around that? So that's what we're going to be talking about today. Just real quick, who we are. I mean, we are part of the community of Hadoop. We have a number of folks who are contributors to a bunch of the different Apache projects, including Mahout and Accumulo and others. And we have a bunch of points of view. These slides will be available afterwards, so please go and click on those, take a look at it. We'll point out one thing at the very end. So the way that we're going to talk a little bit about this is first talking about securing data in Hadoop, what we see, some of the challenges from a high level. We're going to go through an architectural case study that we did, so an actual deployment we did with a client, with a commercial client, and talk about some of the puts and takes we had with that. We talk a little bit about smart data, what that means, and how that plugs into what we see emerging within the Hadoop environment. And then we're going to talk about some of these emerging security capabilities and kind of this convergence that we're seeing across the entire ecosystem. So hopefully that sounds good. If not, then too bad. So securing data in Hadoop. So what we've noticed, a lot of our clients, they are absolutely facing what we have all heard today. We hear in Hadoop community, they are truly facing just a deluge of data. It's a lot of data that a lot of our clients are dealing with. But I think more importantly, what a lot of our clients are struggling with is that data integration, data architecture challenge that they have. The security policies that they actually have to address and the security and compliance things that they have to address don't necessarily give you good controls or good technologies available in order to address those when you're integrating all different disparate types of data together. I mean, that can be everything from like electronic health records with financial data and all these other types of data that when you integrate them together, create maybe new and different problems. And so a lot of our clients, when we go in and discuss this with them, they're not necessarily ready to figure out how to address that challenge. And as you know, many of our clients, and I'm sure you see this in some of your endeavors as well within Hadoop, that we've been building systems in stovepipes for so long. But worse, the way that the security community has chosen to implement certain controls is all around those stovepipes. So for example, if you have a database and it says, okay, I'm going to put all my electronic health records in this one database. I'm going to put all of my security controls around that one silo. When you need to integrate that with other data sources, it becomes very, very difficult. And a lot of the security controls that are out there, just frankly, they don't scale to meet the needs of a lot of the clients that we have. Case in point, if you're familiar with like the SANS top 20 controls to implement, it's kind of a common framework that people use to say, okay, well, is my infrastructure that I'm building, whether Hadoop or otherwise, secure or not? One of the ones just to point out is the controlled access on need to know, which is number 15. And I mean, there's a lot of parts of it, but primarily, step one is an appropriate data classification system. How do you do that when you're taking huge volumes and variety of data from Hadoop and stitching it all together? How do you create that? How do you enforce that across the different layers and different applications that are going to be able to access that? It's not necessarily an easy thing to do.
So any presentation you see on security in Hadoop is going to have these bullet points listed in a slide somewhere. These are the things you need to be concerned about when dealing with securing data in Hadoop at all levels. But what we like to focus on, in addition to thinking about these primary architecture components and the tools that you'll use to implement them, is looking at it from a policy perspective as well, starting with the people, the process, and the culture of your organization, and understanding the security needs as a result of that, instead of focusing on the particular tool vendors and getting locked into something that doesn't provide you a complete solution. So very often you'll find us taking a combination of open source technologies and formulating them into a single stack. You'll see that how we do that in our use case that we show later. And it's really important to highlight to your customers to start small, and that you'll be that security is a continuous process. You'll be continually implementing and evolving that over time, so you're never really finished, whether it be from a policy perspective or a technology perspective. Mm-hmm. So what are some of the Hadoop security challenges when building a Hadoop architecture? You think about things like scale and the frequency with which jobs are kicked off, say, in a MapReduce setting. You can't be going out to an authentication system like Kerberos for all those jobs. It just doesn't scale. You think about HDF in the file system and how you have this sort of two-tier name node level that implements the ACLs, while in the bad old days data nodes, you could just fetch random blocks from them if you were somehow able to expose block information. Once again, you have issues related to job execution as well. When jobs are running on multiple nodes, you have to worry about propagating credentials to those multiple nodes and passing job data around and making sure that job configuration data doesn't expose sensitive information as well. And then multi-tenancy as well, is how do you protect data that's only supposed to be viewed by one group from other groups. And then trust of auxiliary services. And this means like when you're using something like a workflow manager like Uzi or along those lines, how do you pass user credential information into Uzi in a way that it can act as a proxy for users and pass that information onto the underlying systems? Mm-hmm. So one of the big strides forward that was made for security in Hadoop was the release in 2008 of 0.20. It was a Yahoo security patch, something like that. And basically, this was the first release that supported Kerberos for authorization and authentication. And as a result, there was a lot of tokens that were implemented that allow passing of credential information between the different components in Hadoop. A good example of that is sort of like the block access token, where a user would query the name node, or a client would query the name node for a particular block, receive a token from the name node that says, yeah, it's okay that this client accesses this block on the data node, and thus pass that block access token to the data node. You have a lot of symmetric encryption, which means shared keys. And one of the problems with that is with a large cluster, you have thousands of copies of these shared keys distributed across the cluster, which is increasing your attack surface. And then some of the performance goals of the original development team was less than a 3% impact. And that sort of leads to a default SASL quality protection out of the box that just provides you authorization but doesn't provide you encryption or data integrity protection. And then this notion of a pluggable authentication literally was left to the end user. Now, some of these things have changed recently. There were alternatives at that time. Some folks at Booz Allen were looking at using Tahoe least access file system to provide protection of the data in HDFS as an alternate to HDFS. But things have gotten better over time. And with the Hadoop 2 release, we have a bunch of different things that are secured. And so sort of these are the three different main things that needed to be secured in the Hadoop 2 release to provide the level of protection required by different organizations, such as Hadoop RPC, providing a SASL layer that passes all the RPC calls and can protect it either through authorization, integrity protection, and confidentiality, depending on the quality of protection that's set. and that's used for communication between MapReduce jobs and the various Hadoop daemons. You have cases where there is direct TCP communication between Hadoop clients and the data nodes, and there's a HDFS patch 3437 that was used to implement tunneling that data through SASL. And then HTTP, you have to be concerned about how clients are accessing the web UI, how the HTTP operations between the secondary name node and the name node when it comes to transferring file system image information are protected. One of the really cool things is the ability to implement a reloadable Java key store. I don't know if any of you guys have really dealt a whole lot with the SSL in Hadoop, but of course you're stuck without a reloadable key store. You don't have a way to easily and quickly revoke permissions for clients that no longer should be trusted. And then there are some other patches worth looking at for MapReduce for 4417 and Hadoop 8581. So a lot of these foundational things have come online as of 202 or the 2.0 alpha series, and now are fully mature, more mature in 2.3 or 2.4.0.
Yeah, and what we have seen is a lot of our clients who were early adopters of Hadoop are now looking to move to these newer architectures, but some of the legacy things still are applicable to them. So we have one architectural case study. I don't know why we called it architectural case study. Anyway, This is a case study. This is the lessons learned. This is the body of our presentation. And it's really all around a multinational Fortune 500 company that we work with. They have over 100,000 employees, and they have multiple data sources for each business unit. So they have a research and development unit, which is about 10,000 people. They've got manufacturing, which is pretty big SAP deployment, among other things. They've got sales and marketing. They actually have to pay their salespeople based on how well they're able to calculate how much they sold, so forth. And then, of course, there's just corporate metrics that they need to do. These are kind of the major sources of data that they all had. And they wanted to combine that data, but there's a lot of sensitivity around, did they really want sales and marketing to be able to see what the research and development folks are doing? Probably not, right? I mean, sales and marketing would probably jump on and be like, hey, we're going to sell you the latest and greatest. It's coming down the pike. I got this inside track. Maybe not, I don't know. But they wanted to make sure that all of these different corporate units and individual teams, even within each of those units, were able to still get the benefit of doing the analysis and the search and understanding what all the data was available throughout the entire enterprise, but at the same time lock down certain pieces of data so others couldn't access that as appropriate. Efforts to do this previously, before we came in, was really interesting. Each one of them had failed. They had paid lots of money. They'd spent about 10 years trying to do this. Each one had failed, and the biggest reason why was their CISO would not sign off on the risk of combining all of that data. So that was really interesting. There's still a lot of concerns around that. What we did was we decided to work directly with the CISO and the security organization to define exactly what they thought those risks could be, and then we designed an architecture that could address those risks. But one of the key learnings, at least for us, was pulling them in early in the process and getting them to agree and sign off on things in an iterative approach actually made a big difference and allowed the IT team that was really wanted to move forward with this and knew it was a really good solution to implement a Hadoop-based system. It allowed them to get a lot of that kind of executive sponsorship early on, which was really key. So the design goals around it was, build a fully realized data lake. So, a Hadoop and a Cumulo and other components we'll show you in a minute. They really wanted to protect unauthorized release or modification of information in certain cases, especially in R&D. They don't want their most impressive and most advanced designs that are sitting on a Hadoop cluster. They don't want people to just take them and go sell them somewhere, or they don't want them to leak, and they also don't want potentially other teams within the R&D department to necessarily know that they're working on this new and exciting thing. And there was a lot of compliance reasons for that as well for this particular industry. We also wanted to enable the use of different components from the Hadoop enterprise. So as you all know from building Hadoop systems, it's not just install Hadoop and you wipe your hands and you're done and everybody goes to the after party, right? That's not how it works. You have to layer multiple different things together. And how do you layer all those multiple things together, but at the still time address the security that is unevenly supported in all of those different components during that, through that architecture. So just to throw up here, I mean, because we do this, have done this for many, many clients over the last 7 years, we put together what we look at as our common reference architecture for being able to do this. And it's just blocks. It doesn't actually have technologies on purpose, because a lot of our clients have some already deployed technologies that are really, really good, and they want to be able to leverage that. And so piecing together an architecture that is both secure and scalable for them this is our way of kind of visualizing how we did that. And so we use this and all of the design principles within this that we've learned over multiple engagements with this commercial client. But the really important part of this, the only reason why we bring this up is at the data lake, the metadata tagging and the data lake and all of that component, which we're going to talk about around smart data. That's a key way of actually addressing a lot of the different multivariate security concerns.
So this is a picture of the architecture that we put together for a particular use case. What we have primarily here is requirements to build a full text search application and distributed query processing layer. That is exposed as a web app. Security is provided by both SSL and PKI authentication to that web app. And roles are synced from an external LDAP server that's maintained by the enterprise. One of the interesting things you'll see here, and I'll touch on a little bit later, is that we built this all on the Amazon VPC platform, and I'll get into the reasons in detail a little bit later, but it provided us some basic security capabilities out of the gate. And so from there, we're streaming ingest using some custom ingest capabilities implemented in Scoop. We have a streaming portion of ingest that's sort of it's a future architectural build-out capability. And we provide, in addition to the custom designed web app to support full text search, we supported BI type queries via the Hive layer.
Yep.
All of that is accessible via the Amazon Direct Connect from the corporate intranet.
And it might be my glasses, but this looks like super fuzzy. So if you can't read like the individual text, hopefully that's not just me, but because that means I'm also maybe passing out. But these slides, this one, you'll be able to actually see. And what's the thing that when you actually go and look at it on the website, what's kind of important about this is just look at the arrows, because the arrows describe kind of how these things integrate together. And there are things in there like the encrypted data volumes and network ACLs and all that stuff he's going to talk about. But one of the key things is the Knox gateway. Are you going to talk about the Knox gateway?
Absolutely.
Okay, yeah. So I'll shut up and let you do yours.
So just to up arrow one more. So basically, this is implemented as an enclave. We do not provide access to the individual Hadoop nodes to users on the network. And we secure access to the cluster using the Knox gateway. We can talk a little bit about how we're using the web services that are exposed by Knox to proxy access to different backend services, and a little bit of a customization we added to Knox to provide administrative access for privileged users. Okay, so the too long didn't read version of that architecture diagram are these bullets. Repeating myself a little bit, data loading via Scoop and custom transport, ingest and index into our full text search via MapReduce. We do distributed query versus using Storm and Lucene. Not going to talk a lot about that in this talk. If you guys want to learn a little bit more about that, just come talk to me later. I'm a search geek. Anyway, batch reporting via Hive, via the interface through Knox to Hive Server 2, authentication via Kerberos, and access via web application in Knox. The other thing that's interesting that a lot of people ask us about is how do you get to the Hadoop web interfaces to manage Hadoop and things like that? And we've found that we don't need them very often, or we've been able to meet the needs of what those user interfaces are typically used for through other means. And just to give you a little bit idea about the scale, it's currently 100 terabytes with about 50% usage, and we're looking at 150 terabytes by the end of the year. So let's see, infrastructure and network security, we talked about. Amazon, it's provided by Amazon Web Services, like the low-level infrastructure is provided by Amazon Web Services using a combination of their virtual private cloud capabilities and security groups. The virtual private cloud, for those of you who aren't really familiar with it, essentially gives you an isolated subnet in Amazon that is also an isolated VLAN, so you don't have to worry as much about man-in-the-middle attacks or network sniffing type approaches. And really, a thing that made it really great for us, in addition to them handling things like physical security and all those things you need to be afraid of when you are thinking about security in a data center environment is that the time to deployment for early phases of this project was significantly shortened. From past experience, clients who are trying to stand up their own secure cloud infrastructure, the lead time is somewhere in the order of 3 to 6 months between racking and stacking, getting the policy in place and the security staff on board. It's a significant effort. So being able to get out the gate with Amazon VPC and satisfying the CISO with that was a big deal for us. And of course, we do instance level malware detection. Malware detection isn't that special, but essential for this particular case. And we tuned it to coexist with cluster workloads. All right, so encryption. We had concerns about ephemeral volumes and the ability to recover data from ephemeral volumes on Amazon. So we rolled our own using Lux, which is the Linux unified key setup capability that runs on top of the decrypt layer in the Linux kernel. And since they were ephemeral volumes, we didn't really care a whole lot about key management because we didn't have to. If we lost a node in our Hadoop cluster, it would be gone anyway. The ephemeral volume would be gone. So we would never really need to decrypt the volume once the volume was set up. So we literally locked it up and threw away the key. And then in transit, of course, we were using SSL to the web app endpoints and to the Knox gateway. On the inside, we were also using SSL between Knox and the various Hadoop services using SPNGO authentication. And then, as I said, we had internal network isolation due to the VPC. So authentication was handled via Kerberos, authorization via external LDAP. There's a future transition to enterprise authentication services via Oracle IAM. And that was really driven by the fact that we needed to apply fine-grained access controls to the data, which we'll get into later when we start talking a little bit about the smart data portion of this project. And then we used multi-factor authentication for both users and devices via PKI. And this sort of highlights one of the other interesting requirements for this work is that users could access data from a variety of devices. A good example, representative, would be the fact that somebody might have access to a piece of data from their local PC and their smartphone at the same time. So when we made access decisions, we were actually making access decisions based on both the user's roles and groups assigned in LDAP, but also the device permissions for the profile of the device. And then for privileged access management, we basically locked down the operating system so that there were user accounts there, but they weren't able to be, there's no pathway to actually log into these nodes from a Bastion host or something along those lines. We did some work on a Knox plugin that's described a little bit in Knox 250 that provided limited access via SSH to the internal machines for various operations from the administrative level. This doesn't really provide a full level of data quality protection in that administrators would still theoretically be able to access data on HDFS. So there wasn't a full separation of concerns, so to speak, but that's something we can adopt over time. And so putting it all together, once again, the search UI is a web application access via SSL. Knox was the primary cluster access mechanism for users who need access to the cluster, providing access to things like web HDFS, HCAT, Hive, and Oozie. A good example of that is MapReduce jobs to actually ingest data from external sources were kicked off via Knox. And we used Knox for administrative access to the cluster via the SSH plugin that we had in place. Mm-hmm. So future directions. So a finer grained role-based access control is a need for the client. And so to enable us to do that, you don't get, I would say the ability to pass things like low-level data visibility capabilities. So if you think about cell-based access control, things like that, from an external identity solution down through the infrastructure into something at a lower level, for instance, like a Cumulo, is not quite there. It's not quite plumbed through in all the parts of the ecosystem. So I think that's really important that we look at ways to be able to pass additional information from the web app down through the Knox backend. And then that also, we are working on some role-based access control, low-level cell-level security type stuff for Lucene indexes as well, so that the documents returned and metadata within the documents that are returned from a search, for instance, is appropriately masked based on the access control level of a user. And then we'll talk a little bit about that in detail as we describe the smart data tagging strategy that we advocate.
So all of that to say, we still aren't able with this client to be able to understand the user and the exact policies that the individual user, the attributes of that user, and apply that against the data in this particular client engagement. And so the client approached us and said, okay, next phase is we need to be able to do that, right? No kidding, we're going to do that. And so what we are implementing right now with them is what we're calling a smart data strategy. So we can talk a little bit about kind of what that is, but quick show of hands for all of you who are working with Hadoop. I mean, have you seen in your organizations or in your deployment to Hadoop this need for very fine-grained policy decisions and access controls within your cluster? So quick show of hands. So yes, I have. No, I haven't. Yes, everybody has. Wow. This is a smart crowd. Awesome. So the way that you were able to do that, right, is all through attribute-based access control. So the ability for you to have very fine grain, and when I mean fine grain, what we usually talk about is like an individual cell of data. So if you think about like a key value store like a Cumulo and the visibility tags that you get within the key portion of that, what do you put in that, right? How do you map policies and HIPAA or PCI or other types of things against a set of tags that are regular expression in there that will actually help you to secure those authorization decisions that need to be made at scale, right? So lots of users, lots of interactions. What we are working with our client on is, first of all, to come up, what is the definition of those tags, right? How do you do that? What standard is that based on? There's lots of good ways of doing that via XACML and other things. But an overview, just a quick overview of our design principles is you have to be able to do a number of different things. So first is you have to have PKI, right? You have to have some way of knowing that if you're going to apply visibility tags to a cell of data, that visibility tag isn't changed, right? Because you can't have, for example, everything that is privately tagged and the word private is in there, all of a sudden change to public and all of your keys of your data are then exposed, right? So you have to have some way of binding that, and you usually, PKI is the way that we've done that. You have to have some sort of identity and access management controls that can actually understand user attributes and what those mean and how those actually map to the data. And we'll show you a really horrible diagram that I drew because of my terrible graphic arts skills on the next slide, but it kind of goes over how that all works. You have to have that trusted data format based on whatever your policies and so forth are. You have to be able to tag all of your data, which sounds simple, but in practice actually is quite difficult. You have to make decisions up front onto what data sources you're going to take, how you're going to tag them, and then there are ways for you to maybe apply different regular expressions to say if it includes maybe a social security number or a credit card number, and we know that because of this regular expression, you could tag it a certain way or not, but the sophistication level of the tools that are out there right now aren't as high as to be able to get, you'd be able to do that in an automated fashion. It's still very manual. And then you have to have your Hadoop platform be able to obviously support those different types of tags. And then obviously, the most important thing is you have to log, monitor, and audit everything. So every interaction of every user, of every node, of every network access to your cluster and your individual pieces of data have to be audited. You have to go and look and see, oh, well, these people probably shouldn't have accessed this that did. So just a quick overview. Apologize for my terrible graphic arts skills, but this is just like an overview of how a system like this generally is constructed at a very, very high level, like super high level with like the crazy faceless person is the user, right? That's how we see all of our users is no face, right? Just a random person from the head up. That user will have PKI, username and password. They'll get authentication and authorization from the identity management system. And what that will do is assign a series of attributes to that particular user. For simplicity's sake, it's red, comma orange, comma blue here, this user, say this is me, right? So I go into my system, I authenticate my PKI, and the system then is passed to our cluster that is running Apache Cumulo, and it says, okay, Peter is red, orange, blue, whatever. When your data comes in, then you have visibility tags applied to it, and that can be red or blue or green. It could be red and blue and orange and green. It could be a combination of things, but the data is then tagged. All of that is stored and regulated not only in Apache Accumulo, so once it gets ingested and tagged and put into Accumulo, and indexed and all that stuff, all regulation access to that has to be passed down through every single layer, which is some of the challenge that we've seen. So for example, one of the things that is really interesting about data visibility and some design decisions that have to be made up front is these notions of how you actually are going to describe the authorization of who gets to use it in what situations. And this can get extremely complex, right? I mean, this is a white page, right? You can get very complex, you can get very complex. An example could be, like, for example, down here is an actual XACTML rule that says, I want to allow access to this resource, medical journal, which is the resource, with the attributes patient ID equals X if and only if subject matches designated doctor of patient and action is read. So this means if I'm a doctor of a patient, I can read a medical journal entry. Only if and only that's all I can do. I can't do anything else. And then you always have an obligation. So then the obligation is, on the permit, when you do that, you log it. Say, Dr. Peter, for lack of better words, has looked at this patient's record, and you store that. And then you audit that. And you're like, yep, that's his doctor, and that's okay. There's a whole bunch of parts of this entire ecosystem that have to be implemented and all working together in concert, though, in order for it to actually provide the protection. And I think that's one really key point that we're working with our client right now. One of the long poles in the tent for our client is that not necessarily the technology of this, although that's a challenge because not every layer or every piece in the Hadoop ecosystem right now will support this type of fine-grained access control. It doesn't as exists today. 6 months from now, maybe, but today it doesn't. So having to build and future-proof, remember Amsterdam, are we building something now that later on won't be applicable? But there's a whole bunch of different parts of the tagging and the syntax and all of that is the longest pole in the tent, and we're working with their legal and so forth. But just some of the things that we've noticed, and Drew's going to talk a little bit about, when you're actually implementing some sort of smart data, like what are some of the best lessons learned? What are some of the things that, very fine technically do you need to address?
So these visibility markings that we talked about, using Apache Accumulo as an example, are arbitrarily complex Boolean expressions, and you should take advantage of that power when marking your data. Don't restrict your data to just a simple single 4 characters tags. The database engine, the engine underneath Accumulo can handle automatically compressing out duplicate data very effectively. So have long tags, and as a result of being able to support that, you can have a very rich taxonomy of tags so that individual data items are marked with tags based on the origin, where they came from, what level of access control or sensitivity is associated with this particular cell of the data, even what sort of information governance policy is associated with this data. So for instance, you can begin to age off or purge data from your database based on the tags that you've assigned to it. Also things like data owners, who does this data belong to, or who are the intended recipients of this data, also can be things that get rolled into tags. What you'll end up with is having a very rich taxonomy of tags that is, and the other point is architect your systems so that these tags can grow and change over time, because naturally they will. So think about how they live both on the user role identification side, like in your LDAP server or whatever identity management system you're using, but also alongside the data. And there's something else I wanted to say about that, but I'll come back to it. So use fine-grained tags, assign many roles, tag at the field level, and I think that basically covers it all. Oh, okay, so one other point is there's sort of 2 different types of tags that I'll get into the next slide, but essentially visibility tags are bound to the data in Accumulo. So very often you have to think about, if tags will be changing over time, what's the process for actually removing and re-adding the data tagged at a different level? Generally, you provide really strong binding of data and tag, which is a good thing. You don't want your tags changing arbitrarily over time. You want to make it sort of difficult to rewrite tags, but also think about how you might have to have a process to support that in place. So This is a little bit deep, but let's see how it goes. We have this notion of representational versus referential tags. I talked about writing tags alongside the data so that the effect of those tags doesn't change over time. Well, if you don't have that requirement, or if your particular use case involves the potential for lots of tag security to change over time, think about maybe implementing what I call a referential tag system, where you have maybe tags that get resolved to a variety of access controls at query time. So what actually happens is in your LDAP system, you might have a bunch of roles and groups defined for your users in terms of what data they can see, what organizations they belong to. These get merged down into referential tags that are short identifiers. The full set of referential tags that could be expressed by the combination of their roles is emitted by the identity system and then correlated with the data that's embedded in the database. So hope that makes sense.
Yeah, so that was a super high level, super quick, like here's what we're doing around smart data. For one of our clients, we've implemented these systems over multiple clients with a lot of clients who have a need for these kind of multi-tenant data lake architectures as they are either servicing other clients or serving as internal clients and so forth. But when we were doing this presentation, literally like a month ago, the entire security ecosystem for Hadoop has started to change, if you all haven't noticed. There's a lot of this space that is, it's really interesting just how much is going on in this space. And we only have a couple minutes, so you just want to sum up this slide real quick?
Sure, so both Cloudera and Hortonworks are doing really interesting things around the space, and the various open source projects that they support, and the folks working on other projects related to that as well. I have a number of tickets from Intel Rhino that are really interesting if you are looking at encrypting data on HDFS and managing keys at both MapReduce time and handling transparent encryption for things like HBase and Zookeeper. Cloudera has Sentry that provides ACLs on top of Hive that's worth and Impala worth taking a look at, and Gazang for file system encryption. There's an announced acquisition today by Cloudera. Hortonworks is really leading the charge with Knox. Knox is a really great product. I've had a lot of great experience working with it personally on this project, and it does what we need it to do. Also, the acquisition of XA Secure promises to do interesting things in the future in terms of centralizing administration for HBase, Hive, and HDFS. Yeah,
and no guarantee, but we just put up here, I thought it was interesting that at least 4, it looked like really good talks that are coming up at this summit all around what the future is, like how they are moving, right? So where are these different conversions happening? Are you going to use Gazang? Are you going to use Lux? Are you going to use other things? How is that going to be wrapped into the whole holistic Hadoop ecosystem? I think is really interesting. I think one of the things that we're seeing is there's still a lot of space and need and desire for more of a smart data strategy. And then I think it's going to be really interesting kind of next 6 to 12 months to see how this space changes and evolves with all these acquisitions and conversions and so forth. So this is a summary. Security has come a long way. It's just changing rapidly. It seems like it's changing every single day, and that's pretty interesting. And I think that's a good thing because that means that Hadoop is moving more and more into the enterprise and it's becoming more core of our clients' businesses, which is a good thing on a number of fronts. We believe that smart data using attribute-based access controls in other ways is one of the best ways of being able to segment your data within these architectures. Happy to talk more about that later. I did want to leave you with, we released a field guide to data science. So this is kind of all of our data science geekery. It's a free ebook. You can just go to boozallen.com/datascience and download it. It's all of our kind of thinking around applying analytics at scale. And there's some in there as well around things that we've done in the cybersecurity realm. And that's us on Twitter. And we have 1 minute and 20 seconds for questions. Awesome. So thank you. Yes. Yeah, great questions. The question for those who couldn't hear was, did we look at MapR as well? We know the MapR guys really well, Ted Dunning and so forth. And I think what's interesting is there's the Hadoop base layer, which is kind of like, I look at it as like a glass container. And that could be MapR, it could be Cloudera, it could be Hortonworks. And each one of them is starting to really pay a lot of attention to the security of that glass container, right? You fill it with marbles and you can see all of them, right? How do you protect that and segment it? I don't know of any specific implementation we've ever done with MapR, but that doesn't mean that we haven't. So as I said, it'll be really interesting to see what happens in the next 6 months, because I see an arms race where people are going to start trying to have the best security on each distribution and so forth, which can only be a good thing for the community. So, any other questions? Everybody's just kind of fallen asleep from the carbs. All right, well, thank you. Really appreciate it. We'll be around after. Thanks.